Okay, so we know what a function is. How do we go about creating one? How do we define a function? Well, we simply write some code, enclose those code statements in parentheses, the curly brackets, don't forget the curly brackets, give the result a unique name. When I say a unique name, I mean you can't have two functions both called main, and you can't have two functions both called printf. That would be kind of dumb, because you'd never know which one you were trying to call if you called it. So you give it a name, hopefully a unique one, and ensure that the resulting code is not sitting inside a main or inside any other function. I'll show you an example of what that looks like in just a moment. Okay, so that will create your function. Here's an example of that. Created myself a little function, a little one-line function called greet. And the one line of code is simply the printf hello world. We've seen that before. Now we enclose that in parentheses, as you can see, give the result a unique name. As far as I know, there is no other function anywhere in the standard C library or anywhere else that I know of called greet. So that's the unique name. Notice the two round brackets after the word greet, they are required. And then that will be situated outside the main function. It will not be considered part of the main function at all. If you come from a language of Pascal, you notice that you can have nested functions. You can have a function within a function, or a procedure within a procedure. Here you cannot do that. All functions are on the same level. Once you have created your function, it's simply then a matter of using it, or, as we say, calling it. So, calling a function. The above example, the greet function, may be called as follows. In your main, for example, you could simply call it like that. You can say greet. Notice I put the word greet there. I could put the word greet there again, like so. Okay, so there's the function called twice in main, which means the words hello world will be printed out twice. Now, if you needed the words hello to be printed out twice, this would be a great way to do it, because you've got less repetitive code. Think about it, you really do. I know you've got two occurrences of the word greet here, but really you do have less repetitive code because you don't have to write out the words hello world twice. For example, if you decided that you now wanted to print out the words this is a really nice day, you'd only have to change that once in the code. You'd have to go into the greet function, make the change, but you wouldn't have to change main at all. Okay, let's have a look at some coding examples regarding functions. Okay, I've got a program here called function.c, and I'm going to now use it to, let's say, read into numbers, add them together and print out the result. But I want to do all of that as a function, which will enable me to do it twice or even 3 times if I need to. So, let's write a function to do it. What shall we call the function? We'll call it add. So you might as well start like that. That's how I always start. The name of the function, a couple of curly brackets, and the round brackets after the word add, and we're ready to go. So now we know how to do this. I'll just pause the video and just fill all the blanks in myself. Just 1 second. Okay, so I've completed the function. As you can imagine, it's just code that you've seen 100 times before. A couple of numbers and a total, printf, scanf, add them together and do a printf. Okay, so it looks just like a main, except it's not called main, it's called add. Okay, excellent. So, great. Well, let's run the program and use it. Let's see if it works. Compile. Okay, and run. It's not doing anything. It's not doing anything. It's odd. Okay. Can you guess why it's not doing anything? Code looks pretty straightforward. Okay, well, I'll tell you what the answer is. The answer is nothing to do with this code that we've written. This code that we've written is fine. Well, I assume that it's fine. We haven't really fully tested it yet, but I'm assuming that it is. It's down here in the main. What does the main do? Well, you come in here, and you run this line of code first, and then this line of code second, and that's the whole program. This may be up here just before main, the add program, the add function, I'm sorry, but that does not mean that it gets run before main does. This is very, very important. If you've never seen a subroutine before, this will probably confuse you. If you've seen subroutines, procedures, functions before in the past in other languages, then this will be very, very obvious to you. So you can skip this little bit. But for the rest of you, just because I've written out this function does not mean that it's ever going to get run. The only way it will ever get run is when I tell it to get run. It's like I've written a little sub-program within my program, and the only way that program is ever going to run is if I say, please run that program now. But I haven't said anywhere that I actually want to run that code. I've written it, I've written those, whatever, 15 lines of code, but I haven't said anywhere that I want them to be run. So, let's do that. I've got to do that in main. Somewhere in main, I've got to say that I want to run the function called add. So let's do that. Okay, that's it. That's all there is to it. That will run the function called add. And that will run it twice. And I could stick it in a while loop and run it as many times as I wanted. Interesting. Okay, well, let's see if that works first. Go. No errors still. Now we'll run it. Now we're getting some output. Excellent. Okay, so first time was 12 and then 23. And this time it's 35, so it's obviously working. The point is, that's how you get it started. You must add a line to your main program. Well, actually, that's not entirely true. You must add a function. You must add a call to your function somewhere. You can't add it up here, but you could add it to another function that you've already got that is called by main. Maybe, well, let me show you an example. We'll write a program called runIt. We'll write a function, sorry, called runIt. And all it does is it runs add. That's its sole purpose in life, is to run add. And we can put out a line saying, add has been run, or something to that effect. This is for all the people that aren't really familiar with functions yet. And now we can say, run it. So what will happen is the very first thing you'll do when you come into main is that line of code will get executed, which means that immediately you'll jump up here and execute all of that. So the first line of code that gets executed in here is that, which means, follow me if you can, that it will jump immediately up to here and run these lines of code. So it'll go walk, walk, walk all the way down through these lines of code, do that printf, add will be completed. So as far as the program is concerned, that line has now been successfully run. So now it will run that line of code, and when that line of code is being successfully run, the program will say, okay, run it is now completed. It'll jump back down to that line of code and continue on from there. In other words, it'll run that line of code and then that line of code. Do you get what's going on here? We're jumping all around the place. So to clarify what I said earlier, you don't have to call the function add directly from main. You can call it via an intermediary function if you want to, like I've done here. Add is certainly being called. The only way that we're ever going to get all of this code here to run is if we call it. And there is an example of where it's being called. Now, it doesn't have to be called from main, but it does have to be called at some point. And there it is. And you can't call yourself. I mean, well, you can, but calling it here is certainly not going to achieve the desired effect. It will do something, but I'm going to talk about that a bit later in the chapter, what that might actually do. Okay. As you can probably imagine, we could now run add a couple of times. So I could copy and paste this code, copy, and maybe paste. And I could say add has been run again. Let's test that and see if it works. Okay, no errors. Add has been run. Notice that. Now into the floor. It's running a second time, 56, and 23 is 179. Add has been run again. So, okay, I know this is a very simple program and not a particularly useful program, but if it was a useful program, if the additions that it was carrying out for us were something that we vitally relied on, we've now run them twice, but we've only written out the code to do it once. And we could run them a dozen times and still having only written out the code once. Okay, I'm going to expand this program slightly. I'll do a little copying and pasting from another program that we've seen before, and I'll just pause this while I do it. No time will pass for you. Okay, took a few minutes for me, but only a millisecond for you. I've now modified the main a little bit. Okay, here we are at the main, The very first thing is I ask them what they'd like to do, and I'm instructing them to either type in the word times or the word add. And if they type in times, in other words, I compare their answer with the word times, then I run a function called times table. Where did that come from? Well, I dragged it in here from another. I did a little copy and paste. Remember this? The grid size of 16 and all that stuff? That's our times table function. Remember that? Okay, well I've brought it in here. It used to say main, like that. But I've simply renamed it as times table, which is very handy. And I've still got the add function, and run it is still there as before. So we either run times table or we run add we run it via the function called runIt. Otherwise I print out I don't know what you want to do, and that's the end of the program. Okay, so let's run that. Okay, compiles and run. What would you like to do? Well, I'd like to try and add. Enter the first number, 23, 34, 57. Add has been run. Excellent. Good. Let's try and run it again. This time we'll give it a different answer. Times. Oh, we get the times table. Great. And I'll run it a third time. And I'll type in help. I don't know what you want to do. Okay, so that's not much help. But at least you get the general idea. The program is working. So essentially this program is now being chunked. It's been broken up into small chunks. We've got a chunk that does this. We've got a chunk that does this. And then we've got a third chunk, which is the main, that decides which of the first two chunks we want to do. Which is nice. Now I could have done all of that in the main. It would have been quite easy to do that. All I would have had to do was copy and paste all the code from the times table function and put it there, and copy all the code from the runIt and the add function and put it there. And it all will still have worked. However, it's not chunked enough. We would have only had one big main program that does absolutely everything. And now if I determined that there was a bug in the times table routine, it's very easy for me to go straight to the times table routine and figure out, well, the bug has to be in that code somewhere. It has to be. Can't really have anything to do with this code. I can ignore this code completely because the bug is in the times table routine. But as you can see, it's making maintenance much easier for me. It's also much easier for me to come back to this program months later when I've forgotten what it does and try and identify all the bits that it does. Think, okay, I've got a function that does this, and I've got another function that does that, and then I've got a main that runs them both together. It's a much simpler way. I can get an overview of the entire program just by looking at those 7 lines of code, 6 lines, I'm sorry. Anyway, that's going to serve as our main example for functions. Let's move on. Let's see what else we can do with functions in the next module.